The energy required to convert reactants into the transition state is known as activation energy. You guys still remember that now, the energy profile. You remember the energy profile, right? This guy here. You guys remember this guy. This is the energy profile. Okay. The highest energy arrangement on a reaction energy profile is known as the transition state. That's the highest. That's the highest. So it goes like this and comes down again. This part here is the transition state. Okay. That's the highest. The slowest step in a multi-step reaction is called the rate determining step. That part that is slow is what determines the whole reaction. Determines the rate of the reaction. 39. Which statement correctly distinguishes a transition state from a reaction immediately? Which of the following distinguishes a transition state from a reaction immediate? A transition state is a maximum energy state. We already established that, so you already know option B is correct. So a transition state is a maximum energy state. Why? Intermediate, not immediate. The intermediate exists between reaction steps. Okay. Number 40. Which of the following is a major application of organic chemistry? The major application of organic chemistry is pharmaceutical production. Okay. The first member of the alkane homologous series is known as ethane. 42. The first member of the alkyne homologous series is known as the ethane. There's one funny question they ask again. Do not ask you what is the eighth member. So you know that the first member is not actually starting from eth. So you should know that the eighth member is not going to be oct, it's going to be none. Right? So let's move on. 43. Successive members of a homologous series differ by CH2. Okay. 44. Alkanes are described as saturated hydrocarbons because they have the maximum number of hydrogen atoms for their carbon skeleton. That's why they are described as saturated. No, in secondary school there was this, because it's single bonded, because it's double bonded. You're actually correct if it's single bonded saturated, but that's not the actual reason. The actual reason is because if you look at this carbon now, you have C, you have H, so you have H and you have H and you have H. The bonds are it's already saturated. There's no space again. It has the maximum number of hydrogen atoms for a carbon skeleton. That's the reason. 45. Which of the following is an isomer of pentane? Isomer of pentane. You guys should know isomer of pentane. 2-methyl-butane. It's a very common question. In fact, you don't need to go there that day and start drawing it to know the isomer. Once you see pentane is 2-methyl-butane. Okay. And that is why you should do well to check that nomenclature video. There is also a video under organic chemistry, how to name organic chemistry. If you can name organic chemistry and you want to practice for your exam, there's also a video for that. Please do well to check out that video. All right. Question 46. The number of structural isomers of pentane is 3. How do you get isomers of structures? Because they can ask you, what is the isomers for, let me say, decane? If you not start drawing on that day, no, you wouldn't draw. How do you get it? How do you get the isomers? You just need to divide by 2. If it is an odd number, then you add 1. What am I trying to say? Let me say butane now. For example, butane is 4. How many isomers does butane have? 4 divided by 2. Butane has 2 isomers. If you go on, pentane 5. 5 divided by 2. That's what? 2. Then we add 1. That's what? 3, because it's odd. So how many isomers does pentane have? 3. That's how we got 3 here. Then you continue. Then if it is 10 divided by 2, of course. 10 divided by 2. That's what? 5. That's how they get what? Isomers. Please take note of that. Number 47. Which pair illustrates chain isomers? That's chain isomers, straight isomers. Butane and 2-methyl-propane. 48. Which pair illustrates position isomers? That is based on their position. That's how they differ structurally. We have but1N and but2N. You know, but1N and but2N, they are actually the same thing. The only difference is just that the position is different. Okay, 49. Which pair represents functional group isomerism? We have ethanol and methane. This is a very common. So you might see questions like this. Option B is an isomer. Option C is an isomer, but it is not functional group isomer. So you should take note of your questions, understand your questions very well. Okay. Moving on, the carbon atoms in an alkane double bond are generally dashed. We have done this before. If you understand the hybridization, you get this question. sp2. Okay. The carbon atom involved in an alkyne triple bond is defined as, of course, sp. I've explained it also. It's just another format of asking the question. Okay. 52. The geometry around each carbon atom of ethane is approximately trigonal planar. You should also know the geometry for others. Very, very important. 53. The geometry around each carbon atom of ethane is approximately linear. Ethane. 1, 2, 3, H. 1 2 3 H. You can see straight, it is linear. Okay, a carbon to carbon double bond consists of one pi bond and one sigma bond. Okay, one pi bond and one sigma bond. Number 55, a carbon to carbon triple bond consists of what? It consists of one sigma bond and 2 pi. This you should not forget, please, I beg you. They can ask you how many pi bonds are in this structure. Once you know, is it structure triple bond, is it double bond, you can get it. So the trick is, double bond is 1 sigma 1 pi, triple bond is 1 sigma 2 pi. All right. 56, the free rotation around the CC double bond is prevented mainly by the presence of a pi bond. Which reagent is commonly used to test for carbon-carbon double bond? It's a very common test. Bromine water. That's bromine water is used to test for unsaturation. So this question can be rephrased and they will tell you unsaturation. Do not tell you bromine. Do not tell you carbon-to-carbon double bond. Just know it is bromine water. The colorization of bromine water by an alkane indicates dash. It indicates the addition across the CC bond. The initial question and this question are the same thing. It's just different ways of asking these questions. All right. 59. Ethene reacts with bromine to produce 1,2-dibromomethane. 1,2-dibromomethane. Okay. 60. Addition of hydrogen to an alkane in the presence of a suitable catalyst is called hydrogenation. When you add hydrogen, hydrogenation. If you add halogen, it is what? Halogenation. Okay. Which catalyst is commonly used in the hydrogenation of alkenes? It is nickel. Nickel is commonly used. Nickel. Hydrogenation of ethene produces ethane. So when you hydrogenate, you are making that compound become saturated. You know it is hydrogen that makes a compound saturated. So if you are hydrogenating, do you know what you are doing? You are actually making that compound become more saturated. So if it is triple bond, if you hydrogenate, it will go to double bond. If it is double bond, if you hydrogenate, it will go to what? Single bond. It is now what? Saturated. So you can see the process. Addition of water to alkane to form an alcohol is called hydration. Acid catalyzed hydration of ethene produces ethanol. That's how ethanol is produced. According to Markovnikov's rule, during addition of HX to an unsymmetrical alkane, hydrogen generally attaches to the carbon having more hydrogen atoms. Okay. 66. Propane reacts with HBr under normal Markovnikov conditions to give mainly 2-bromopropane. The rules just say it's just converting unsaturated to saturated. You know, propane is unsaturated. When you now add HBr, what happens? The H will go to where the carbon that has more carbon to make it saturated. I don't know if you understand what I'm talking about. So let's say we have C, and C here. This is propane, right? This is propane. Yeah. This is propane. And then you have this carbon. And you're adding plus HBr. Now, once you add, what happens is that this H comes to this part, this carbon here, this particular carbon. That's where this H is going to. Once the H comes here, it makes it balance. So you have propane. It's now saturated. Okay. Anti-Markovnikov addition of HBr to alkane can occur in the presence of peroxides. So it's not going to form 2-bromopropane. The peroxide effect in alkane addition is commonly associated with HBr. No, the previous question must have given you a clue on that. Which alkane can exhibit cis-trans isomerism? But2N can exhibit it. But2N is 1 2 3 4. Right? This is but2N here. But2N. So 1 2. So but2N is going to be here. The double bond is going to be here. Sorry. So we have the double bond to be here. Right? So if it is the same side, it is cis. It's a different side, it is trans. You should know that, right? So but2N undergoes cis-trans isomerism. Geometrical isomerism in alkenes occur mainly because rotation around the double bond is restricted. That is why it occurs. The rotation around the double bond is restricted. In cis-2-butene, the two methyl groups are on the same side. I already said that. Cis is same side, trans is different side. In trans-2-butene, the two methyl groups are on opposite sides. Okay. In the EZ system, the E indicates that the higher priority groups are on the opposite side, EZ system just specifically considers the high priority groups, not other groups. So other groups can be on the opposite side, but it's not necessarily E. It is when the high priority groups on the opposite side, it is now E. If it is on the same side, it is Z. So this is what I used to remember. You have Cis, right? You have Cis. Cis is the same. Cis is the same. That's the acronym. Cis is the same. And in English, you can replace S with Z. UK and US standard. So you can say Cis, something like this. So Z is the same. E is different. Just know that. It's as simple as that. In the EZ system, Z indicates that the high priority groups are on the same side. On the same side. The EZ configuration system is based on the Ingold-Prelog priority rule. If you check your textbook well or your lecture materials, you will see this. These are questions that you should expect, and you must solve a lot of questions. And this is me saying that there are question banks available. So if you're interested in this question bank, do well to reach out to me. I'm going to be dropping a medium you can reach out to me to access these question banks. You access the question bank for the 6 courses with just 2,500 naira. That's the course for the question bank for biochemistry, physics, mathematics, zoo, and course for 2,500.